So here we can see the graph of the cosine function, y equals cosine of x. If we want to see the inverse, we would switch the x and the y and graph x equals cosine of y. And we can see that those graphs reflect over the diagonal line y equals x, so they are inverses. And the x equals cosine of y fails the vertical line test. So it is not a function the way the parent graph of cosine is a function, because that passes the vertical line test. Okay, if we were to amputate this graph at the points where it would pass the vertical line test, that would be at the extrema. So here where the y is equal to pi, that point we could chop off everything above it, and then here at 0, y equals 0, we could amputate the graph everything below, and that would leave us just this interval from 0 to pi in the y direction, and that portion of the inverse would pass the vertical line test and be a function. So when we type in y equals arc cosine of x, right, we can see that that is the interval in which the arc cosine or the cosine inverse is defined. So if I change this to a dashed line, that might make it a little easier to see. Okay, so again, here we can see from 0 to pi in the y direction, right? We're restricting the range or the output of this function, or this inverse. We can see that it's a function. It passes the vertical line test only between that interval 0 to pi. Okay, from 0 to pi over 2, that is quadrant 1, and cosine is positive in quadrant 1. From pi over 2 to pi, that represents quadrant 2 on the unit circle, and cosine is negative in quadrant 2. So these are our principal values in quadrants 1 and 2, with the positive principal values coming from 0 to pi over 2 in quadrant 1, negative principal values in quadrant 2, which is pi over 2 to pi. And we can summarize that in the notes on the front of your notes booklet. The second graph down is our arc cosine or cosine inverse, and that passes the vertical line test and is a function over this restricted range from 0 to pi inclusive. That makes the domain of the inverse -1 to 1 inclusive, and the principal values are coming from quadrant 1, which is from 0 to pi over 2, and they're positive in quadrant 1. Then from pi over 2 to pi, that's quadrant 2, where our principal values are negative. So now in 2a, we're asked to evaluate the arc cosine of root 3 over 2 for all angles in degrees. So remembering our acronym, all students take calculus, the cosine is positive in quadrant 1 and in quadrant 4. So our two solutions would be for one revolution of the circle in quadrants 1 and 4. Okay, we're asked to evaluate in degrees, and the arc cosine of root 3 over 2 is asking us what angle in degrees in quadrant 1 has an x value, an x coordinate of root 3 over 2, and that would be at 30 degrees. So 30 degrees is our principal value, since that's a quadrant 1 angle and it's positive. And if I start at 30 degrees and I rotate one full revolution around the circle, that would be 360 degrees, would get me back to another angle for which the arc cosine is √3/2. So an expression representing all possible angles in degrees would be 30 degrees plus or minus k times 360, where k is an element of the integers. Now that's not the only place, though, where arc cosine of √3/2 evaluates. We also have a quadrant 4 solution, and half the circle, or sorry, the whole circle is 360. So going clockwise then, from 360 into quadrant 4, we would subtract 30 degrees to get 330 degrees. So 330 degrees plus or minus k times 360, where k is an element of the integers, would be the other expression. So these two expressions together represent all angles in degrees that evaluate for the arc cosine of √3/2. Now in 2b, we want to solve the equation 3 minus the cosine of x equals 4. And we're going to start by subtracting that constant to the other side. So now negative cosine of x is equal to 1. Then we'll divide both sides by -1 to isolate that cosine of x. And 1 divided by -1 is -1. Now to undo a cosine of x, we need the inverse. So x is equal to the cosine inverse, which is the arc cosine. Or you could use that notation cosine with a little -1, right? That also means arc cosine. And we should recognize this from our work in the unit circle. This is going to evaluate to pi because pi has an x coordinate of -1. So the exact value would be pi. And that is the only angle over the interval 0 to 2 pi that has an x coordinate of -1. Now, if you're using your calculator, you want to be in radian mode, and we would evaluate the arc cosine of -1, and here you see your decimal approximation for pi. And we're asked to round to 2 decimal places if needed. So if you didn't remember that the exact value is pi, you could get that decimal approximation of 3.14. Just remember to use the approximately equal symbol if you are rounding, and the exactly equal symbol if you are not rounding. So to check these answers, or this answer, rather, we're going to substitute in pi for x. And when we press enter, we get a 4, which matches the answer that we started with. So we know that pi checks. If you were checking your approximation, then you're substituting 3.14, and you're going to get an answer that rounds to 4, 3.9999, etc., which rounds to 4. It's not exact, though, because we used a decimal approximation as our substituted value for x.